Morning, everybody. We have only one more class left, okay? On Thursday. So we are talking about the inverter-based amplifier. So let's see. This inverter can be the most simplified circuit for amplifier. Okay? Then this will be very useful for low power amplifier. Okay? So we talked about one example of this inverter-based actually pseudo differential. We can say fully differential amplifier is nota cell. Okay, that nota cell is we have two branches of amplifier, and then we have a cross-coupled inverter. To control common mode output, okay, and then we have some bias circuit, okay, something like that. Say this is GMD ROD, and then this may be GM2 RO2, okay. This each one is a GM3 RO3, okay. Yeah, so there is some slight error in common mode gain. Okay, for the differential mode gain, say we have GMD, this is GM2 minus GM3 plus all those resistance, right? Resistance in parallel. Yeah, RO drive, RO3, RO2, or something like that. Yeah, this is for differential mode. For the common mode, if you review that, you can see this is just a sum of those three, okay? GMD. And those one of RO things, okay? So there is some, in this calculation, there is some mistake in the current, okay? Say VIC, and then this current should be in the same direction. In the previous lecture, we put some current direction like that. This is, oops, like that. This is no good, right? So if you put current direction in the same direction, you can say common mode gain can be written this way, okay? All right. So let's do some more simulation of this nota cell. Say we used some AC coupling. This AC coupling means, here see I use the capacitor coupling, and then and then see I may need some DC biasing, okay, something like that. I can just directly connect it, or maybe I can use some large resistance in between, okay? Yeah, this is biasing, right? Something like that. That's AC coupling. We used, in this simulation, we used a huge coupling capacitor. We don't use this connecting resistor in the simulation. You can use a large resistor, okay, for biasing. Okay. So you can follow, see, I have a sub-circuit, inverter sub-circuit. say it has just yeah, this inverter sub-circuit is a simple one. One by one NMOS, 3x1 for PMOS, right? That's an inverter. And inverter 10 is just 10 times of that, right? 10 times of this inverter multiplied by 10. So this inverter X is some mismatched one. It has something like, so that mismatched one is okay. I mean, it works anyway. This inverter X is 1 by 1.5, 3 by 1. Yeah, this is pretty much mismatched. NMOS length is mismatched by 50%. Yeah, and then let's just see. Yeah, here I put a sine wave input. This is I10, so I1 0, ground. See, I used only sine 1 kT, right? 1 kT. Amplitude is just 5 millivolt, right? And then I used a huge coupling capacitor in the I1, huge. And then same thing here, but with a different polarity, right? I2. Yeah, this should be IP and IM. So I have my sub-circuit nota cell. Yeah, this nota cell has I1, O1, I have a huge 10 times inverters there. And then let's see. Yeah, 10 times inverters. And then this biasing inverter there, small biasing inverter. And then cross-coupled inverter in inverter X, right? That inverter X thing is connected to DD2. This is connected to supply of DD2. All those are connected to DD. DD is 3.3 volt, right? 3.3 volt. DD2 can be higher or lower than 3.3 volt. Okay. So I have a small inverter there for biasing here. And then, what else? Oops, I need more spacing. So here's what's this thing? Oh yeah, I have I call the nota cell, right? How come this has some copy here? Copy here, let's just see. What's the previous one? Some mistake, right? Some duplicated here. Is it duplication? Yeah, somehow it's duplicated. No? Oh, sorry. I have another cell, okay? I have another cell. Okay, here's, I have a differential mode input for this one. See, did I call nota cell? Not yet. Let's just see. I should have called nota cell before. Oops. Sub-circuit. Where is my differential mode nota cell? Oh, somehow I didn't call it yet. Okay, let's check the code. So here's I have a, yeah, this is the one. Where is the other one? The other nota cell for this coupling. 30, I30, this is the wrong one. So here see, I apply the common mode thing, okay? So we want to see yeah, what I wanted to do is I have the same nota cell, and then for this one, I apply the common mode input with the same polarity, right? See, this one is just a 5 millivolt sine 2 pi 1 kt. This is the same thing, just a common mode input, right? Common mode input. And then the previous one is differential mode input, all right? Something like that. Okay, let's look at the code directory. I think this is the code, okay? How come I cannot go down? Okay, oops. All right. Can I slide down my code? Oh, maybe not. Too long code, right? Okay, let's just look at this one. Yeah. So I want to find my nota cell call. So this is my nota cell's description, right? So I called my nota cell. Actually, I have two nota cells here, right? So for the X7, I will apply differential mode input. For X8, I will apply my common mode input, right? So that's okay. So then, see, this for this I1, I2 thing is connected to this differential mode input. Yeah, here. This differential mode input through capacitors. And then for this X8, I3, I4, I will apply common mode input, okay? Here, through capacitor. So in O3, O4, I will have a common mode output. O1 and O2, I will have a differential mode output, right? Okay? And then I will change this VDD2. So this time this is 4.2 or too large maybe. Okay, let's just simulate this one. So O1, O2 thing is a differential mode output. O3, O4 thing is my common mode output, right? My common mode output is small, but has some finite values, right? O3, O4. Oh, they are here. O3, O4. Oh, how come I cannot put O3? Oh, yeah, good. Oh, I can use this thing. O3. Do I have delta? Or how come I don't have delta? Looks like my delta is somehow I cannot see my delta. I should have dy. I cannot eliminate it. Okay. Anyway, See, notice does not reduce common mode voltage, right? Just amplify differential mode voltage. Let's change. So here's I have a pretty large voltage gain. See, let's change this VDD2. Where is my VDD2? How come? Okay. How come I have something like that? Strange behavior. All right. Let's go to the VDD2. Okay, where is VDD2? Oh yeah, here. 4.2 is pretty large, right? So if I put like 3.6, my gain will be reduced, right? Differential mode gain, because GM3 is reduced. Okay. O1, O2, O3, O4. You see, my differential mode gain is reduced a lot, right? Common mode gain will not change much. Okay. Okay. Any question? No. Okay. Let's continue. So I will delete out this thing.